All right, guys, we're going to talk about heating and the seasons. And when we're talking about seasons, obviously we're talking about like spring, summer, fall, winter, those kind of things. And heating, we're talking about the way that the sun, solar radiation, warms up the air, warms up the earth, warms up the objects of the earth differently. Before we get into that, let's talk about weather versus climate. Now, the first thing I want you guys to keep in mind is there is a big difference on that. Weather changes frequently. You can have a day where it starts off real chilly in the morning, then you get some rain, then a warm front comes in and the clouds part, and suddenly it's very nice and warm and sunny, and it goes great, and you have a nice warm evening, and then you might get fog the next morning and all kinds of stuff. That's just weather. Whereas climate is not a day-to-day change, but it's a change over centuries. It's a change over at least decades. It's a much longer time, and it's kind of a general weather conditions there. So you could say like Washington State gets a lot of rain. Now you may go there on a Monday and it's bright and sunny and beautiful out there. But that means on average throughout a year, they are going to get more rain in Washington State than say Arizona or Texas gets. Right. Or Mexico is going to have a higher temperature in general than parts of Canada. Now that doesn't mean that there can't be really hot days in Canada or a nice breeze come off one of the oceans and hit Mexico and cool down parts of that. But we're talking general ideas. Weather changes day to day. It's like a single data point. And climate is more like a whole bunch of data points. We say, wow, it looks like it rains a lot here, or it's warm a lot, or whatever. Yeah. That's the big difference. Weather changes a lot.
It's cold in the winter.
Exactly. Right? Hot in the summer, cold in the winter, that's climate.
Yep.
All right, let's talk about how the heat hits the earth.
So, yeah, we get, now what's driving most of the weather and the climate
is the sun.
Is the sun, okay?
Drives everything down.
Solar radiation that comes to earth in the form of energy.
Light.
Now what happens is it actually hits the surface of the earth, and this is the first step in what derives the weather.
Yes.
Now here's the thing, and we're going to talk about why this is. At any given moment, the sun is not equally hitting all parts of the earth.
Yeah, all parts.
And it's not because it's cloudy in some places. It has to do with the way the earth's tilted. But
yep, the shape of the earth and the tilt of the earth and its spinning makes it heat different things up differently.
And that's where that term differential comes from.
Yeah, differential.
Things are different in different places, okay? So the key idea here is the sun hits the earth differently in different areas.
Yes, it's not hitting the same, but it always
hits
hits
different. Why that is in a minute. Yep. But before that, let's actually take a trip down memory lane.
Let's go back a little ways here to recap a couple things that we already know.
Dark objects absorb more light than lighter objects.
Yep.
Okay, because lighter objects reflect generally, darker objects
absorb more.
Okay.
On a sunny day.
Well, I want to wear a light shirt, right?
Wear a shirt like that.
This would be too bad.
Not a shirt like this.
Yeah.
Because that's going to, unless you like to be really hot, darker colors are going to soak more of that energy up and warm up your temperature.
Right.
Okay, guys, many factors kind of change or impact how the Earth absorbs the rays from the sun, the energy from the sun. As we mentioned earlier in that, the tilt of the Earth is a big factor. And the Earth does not just sit straight up and down, and it's kind of hard because it's in space and it's relative to all that. But relative to the sun,
stick up the ship. It doesn't go straight up and down. Like, this is the axis here. It goes right through the North Pole and the South Pole. Now you notice it isn't straight up and down.
Nope.
Okay? It is tilted.
23.5 degrees, guys.
It's 23.5 degrees.
Give or take.
So it's at an angle to the sun.
Yep.
And no matter where it is in the sun, it's always tilted in a certain way.
So it's spinning, and the sun's here, and the Earth's moving around the sun, and all kinds of good stuff. And we're going to show you guys a couple demos in class to really drive it home in a very high-tech way. The other thing is the Earth has a nice, cool, spherical, streamlined shape. And not only do physical objects kind of get reflected and bounced off of things, but even energies, such as solar energy from the sun, will be impacted by the shape of the objects that it hits. We're going to talk about that too. So basically tilted and round, if you want the two big take-homes from that.
Right.
The other thing too is where the land masses are. Now we know most of the Earth, at least the surface of the Earth, is mostly water. Water warms and cools at a different rate than land does, than different types of rock or sand or whatever happens to be. So if you're in mountains, are going to cool and heat up at a different rate than sand would heat up, than granite would heat up, than water would heat up. So what it's made out of also impacts the way that it absorbs heat or reflects heat.
Generally, I think land absorbs heat and gets hotter quicker.
Yes, yes, but won't retain it as long.
Right.
And the last one's going to be a big thing. We're going to talk a lot more about this.
We have a whole video on this.
Yeah, and we're going to want to get your opinions on this. So start thinking about this thing. First off, we know a greenhouse is like, if you want to think about those, is a little glass building that grow up plants in, keeps it nice and warm. There's a term out there called greenhouse effect or greenhouse gases, such as our buddy there that we get rid of, carbon dioxide and water. Definitely need
Water
that.
vapor, yeah.
And those things tend to absorb the sun's energy and hold it. And if it's coming geothermal energy off our Earth, it insulates that and kind of holds it nearer the surface of our planet. And this causes the air temperature to go up. So when you insulate something like putting on multiple coats, CO2 and H2O and some other things like ozone and that will insulate and cause the temperature to rise. So those are the 4 big things that are going to affect kind of how temperature affects different parts of the Earth differently.
Yep.
I'll let you take this.
So what do you think the weather would be like if in Gurnee if Earth wasn't tilted? Okay, if you think about it, let's say you are the sun.
Okay, I will be the sun with my big round shiny head.
Step out here a bit, please. Okay, so let's pretend Earth is straight up and down. Okay, now you are the sun. Let's say a ray comes straight at Gurnee there.
Okay,
it's going
right
at
off
this
my
angle,
head.
right? This
Yeah.
angle. So if I kept it straight up and down as I went all the way around you, we're still going at the same exact angle off camera right now, I'm pretty sure. But same exact angle no matter where.
So I'm always hitting it the same at all the time.
Right, so we're getting the same amount of sun's energy at all times.
So it almost be like one
there
big
wouldn't be a
season?
big difference. Yeah, it'd be like the same season all the time. It'd probably be a lot like it is in, I don't know, middle of the fall. Here's the thing. Since Earth is tilted, you'll notice right now, you as the sun, when your rays hit Earth, it's kind of like hitting it, Earth's kind of curved away from it, right?
Like a little ramp.
And that
Bing.
spreads out the sun's rays.
So we're reflecting off of there to a certain degree. It's
Right.
scattering.
It actually has more, it has to do a lot too with the way that, the Earth actually absorbs the sun's energy.
Yeah.
Right? And if it gets scattered out like that, not as much energy gets absorbed per square foot.
Yeah, per square foot.
Therefore,
So
there's
the
not as
area,
much
it's
heat
not as
being created.
focused.
Yeah, therefore it's actually cooler. Now, I'm not going to go around you, but let's pretend we're going around the world, and now the axis is pointed this way at you. Here,
Now it's tilted into the sun a bit more.
Right. So you're getting way more direct sunlight.
Yeah.
Okay. That's like how it is in the summer.
And that's how it goes around in our seasons. So that's kind of what we get there. The summer, it's leaned in a little bit.
So since we're tilted and we move around the Earth, at
Yeah.
different times of the year we're getting different amount of sunlight.
Yeah, and we can show that in class
Okay.
a lot better on there.
Now, if we were a cube,
Yeah, which I'm glad we're not.
we'd probably be blocked from the sunlight.
Yeah,
so,
other than the other physical limitations
Yeah.
that could never happen. But let's
Luckily-
say it did.
Luckily, there are no cubic planets, so this
No,
is not the issue
no.
with really any planet. But
Yeah.
anyway,
But
so-
the spherical shape has a big impact too on how it gets absorbed. So let's kind of wrap this up a little bit here.
Yeah,
Let's
so-
talk about the Earth and the Sun together.
So, yeah, the tilt of our axis is actually the biggest factor in why the seasons change. A lot of people think we're close to the sun in the summer. It's actually not true. We're
That's
close
not
to
true?
the sun in the winter.
That
I
seems
think that might be
crazy.
coming up on a slide,
Let's look
but-
at this because that seems kind of bogus
Yeah,
to
so
me.
anyway, the equinox is the point in which the sun's rays hit directly on the equator. And
Ooh,
actually,
that's
it
an
means
important
the
definition.
sun's rays are going perfectly even towards every part of the Earth during the
So it's
equinox.
getting relatively the same amount of solar energy.
Right.
At the equinox, which is equal amount of solar energy.
And we
that
actually
seems like a
passed the
good tip.
equinox a month ago. But
Yeah.
anyway, so that's when we officially turn to spring is
Yep.
the day in
First
which
day of spring
equinox happens.
2021, something
Yeah.
like that.
Now a solstice is when the rays hit either as far away above the equator or as far away below the equator.
So there's our equator right there.
So summer is when we get the summer solstice, which is June 21st. And we actually like to call it the first day of summer, but
Yeah.
that's really a weird way of putting it. But
Yeah.
that's the day in which we get the most direct sunlight from the sun, being in
Tilted.
the northern hemisphere.
Towards the sun.
In the
Okay.
winter solstice, that's actually the shortest day of the year also.
Yep.
We are tilted the furthest away from the
Yep.
sun.
Back away from it. So that's why it's colder in the winter because we're getting less of the sun's energy. It's kind of like if you think when we're tilted toward the sun, it's kind of like leaning into an oven
Yeah.
or leaning away
Yeah.
from the oven
Yeah, in
and
the
letting the
winter we're
air
sort of
go
leaning
over
away,
you.
in the
In the
fall
winter,
we're
we're
leaning
leaning
forward.
away from that oven.
I said fall. Summer we're leaning forward. Fall and
Yes.
spring we're just kind of standing.
Yep, you're kind of standing still, and in the winter, you're leaning away from the oven, and that's kind of how that works.
Yeah, that's a good analogy. I like that.
There we go. Look
I'm
at
glad
that.
you thought of that.
Let's wrap it all up.
So we're actually closest to the sun on January 3rd every year.
Mm-hmm.
Okay. We are furthest from the sun on July 4th. So 4th of July, we're furthest away from the sun.
That's,
So
weird.
that's why we let off fireworks. No,
there
it's
we
not.
go. To warm up the earth.
It's for
No.
a different reason. But
Yep.
anyway, so although it's usually a very nice day, we're actually furthest away from the sun. So it shows you how much more important the tilt is.
Yep.
Because we are leaning in, as Mr. Harkins said, that
Yeah.
We're getting that direct sunlight and it's warmer.
So you're farther
We're
away,
actually,
but leaning in.
I think a few thousand miles further
It's
away.
only a few thousand miles. It's like 147,000 as opposed to like 153 or something.
Mm.
It's not a big difference, guys. It's maybe 6,000 miles total, which in space, that's like a grain of sand. It's nothing.
Yeah.
All right, we're going to go over more in class, guys. Go do your checkpoint, kick butt on these things, and let's finish strong. Woo!
See you later.